Hello, in the last section we saw the permissions related to the sticky bit, then SGID bit and the SUID bit. Let me do some summarization of that. Sticky bit, which is actually a T bit, is set for directories so that anybody who has the right permission on that directory will still not be able to delete the files owned by other users. So this is the sticky bit T to avoid deletion of files owned by others. So this is what the sticky bit is, and just remember that our temp directory is the best example for the sticky bit. That means anybody can go and create a file in the temp directory because they have the right permission on that, and that right permission is a dangerous permission, because if you have the right permission on any directory, you can delete a file in that directory, and we want to avoid that, and therefore we put a sticky bit to that directory. So you can still create the file in that directory, but you will not be able to delete the files created by other users. Obviously you can delete the files created by yourself, so that is what the sticky bit is for. Now we also saw the SGID bit, and that is exactly what I have written here. Any file created in that directory will have the group ownership of the directory itself. As you already know that anytime I create a file, I am a user, then the files group is going to be the primary group of myself. And if the SGID bit, which is again the S bit at the group level, if that SGID bit is set, then the file that I create will not actually have the group ownership of my primary group, but the group ownership of that file, the group of that file will be the group of the directory in which I am creating it. So that is the S at the G level, G plus S. That is the permission that we give. Here we give O plus T, and the set UID bit, as I said, I will not go into the details of set UID bit, but that is mostly for programmers, and for the files that have been set the set UID bit, you become kind of the owner of that program for the duration of the execution of that program. So that was the summary of what we did last time. I think it was worth going through that summary because it is little complicated to understand these sticky bits, SGID and SUID. Now we're gonna go to the next thing, which is the ACL. ACL stands for Access Control List, and there are only two commands that you need to remember. One is get FACL, get File Access Control List, and set File Access Control List. You can get the information about the permissions that are already set by this command, get access control list, and you can change the permissions by set access control list. Now we already know the commands chmod command, which will allow us to set the permissions, change the permissions on a file, and all that stuff. Then why do we need this additional thing ACL? We need this ACL for a special permission, and when we need to provide permissions to any user other than the owner of the file, and at the same time when we need to provide the permission to any group other than the group of the file or the directory. Just imagine that the file is the ownership of the file is, let us say, by a user called as user1, and the file has a group of Java developer. Now since the user is user1, let me change the spelling here, USER1, then the owner can have certain permissions. Those are the first three digits of your permission. If the group is JDeveloper, that can be also given by the next three characters in the permission, and others are there. So only the owner, the group of the file, and the others, only those three things can be set up. Now the issue is, what about there is a programmers group called as C developer, and we want to give certain permissions to the C developer. That will fall into this scenario. So when we need to provide permission to any other group other than the group of the file, other than the Java developer, let us take another situation. I want to provide a permission only to one specific user. That cannot be done using the chmod command, and that's why we need the access control list concept. So let us see how to work around with that access control list concept. Now I'm going to log in as a user called as or let us say I am root. I'm going to create one file in the temp directory vi/tmp acl.txt, and I will write certain things in that file. I'm going to save this file. Let me go to the temp directory now. ls-lrt will show me this file at the bottom of the list. And now who is the owner of the file? Root. So these are the permissions for the root, these are the permissions for the members of the root group, and these are the permissions for somebody else. Now let us see, I want to have a special permission given to a user called as Shaker. Now Shaker is not the owner, Shaker is not also the member. Then who is Shaker? Shaker is member of others. But if I give permission for Shaker to write in this file, what will happen? Everybody will get the right permission there. So I'm not going to give right permission to others. I'm going to give the right permission only to Shaker, and this is done by doing something like this. Set facl -m is to modify the permission, and I'm going to say a user whose name is Shaker will be given read, write, and execute permission, everything on the file called as acl.txt. Okay, so m is to modify, u is the user, this is the name of the user, and the permissions that are given are read, write, execute. So now if you see the file ls-lrt one more time now, and I will just say acl.txt, you will see the color has changed, and the reason for that is there is a plus sign there. The moment you see a plus sign, that means there has been given some special permission, the access control list permission to this file, and we cannot see that using just the ls-l command, and that can be seen by get facl acl.txt. And as you can see, it shows you that the file is acl.txt, the owner of the file is root, the group of the file is a group named root, the user, that means the owner, this guy, has the read write permission, and then there is another user whose name is Shaker. He has the read write and execute permission, and others have only read permission. So let me now log in as user Shaker. I'm going to log in as user Shaker, and I'm going to try to change this file acl.txt, which is owned by root, and the group ownership is also root. For some reason it is taking long time for me to log in, so let us have some patience. Yes, I'm logged in as user Shaker now. I'm going to the temp directory. I'm not root, I'm not a member of the group root also. How do I find that out? I find out by typing the command groups. Groups command will show me what groups I belong to. I belong to only one group whose name is also Shaker. So what permissions apply to me? Only special permissions. I'm going to say vi/acl.txt, and I'm going to add certain files, and I will be able to save this file by typing :w, and yes, I am able to save the file just only because of the special permission that has been given to me and not to anybody else. So that's about the special permissions.